Let's talk about the chain rule. So the chain rule is the formula that you can see on the screen here. The derivative of f of g of x is f prime of g of x times g prime of x. So the chain rule could also be called the composition rule. So it's how we're going to compute the derivatives of functions that are built from, as you can see in this first example, a function with a derivative rule plugged into another function. All right, so here, like, we're not going to be looking at the product of two functions. This is x squared minus 10 plugged into the x to the fifth function. So when the product and quotient rules don't apply, the chain rule is probably the rule that you need. So we have f is like the outer function, and then g of x will be the inner function. So we'll have outer prime of inner times inner prime. Okay, so this is a little bit trickier than the product and quotient rules. So let's dive into our first example. I have two examples in this video. All right, so this function h of x here, we have x squared minus 10 to the fifth power. All right, so I want to see this. It's not multiplication. It's not division. This is composition, right? Where I have some stuff in the middle here raised to the fifth power. So I can see this. I'm going to write chain rule to remind myself I'm deciding to do the chain. I want to see this as f of g of x. And I want to decide what the f and g are. So the outermost thing happening is this to the fifth power, right? It's a bunch of stuff to the fifth overall. So my outer function f is going to be that fifth power. And then I can make the g x squared minus 10. And really, I have to have some sort of x in here. So this is going to be x to the fifth power. So when I plug this into that, I get exactly my function back, right? So f of g of x will give me what I started with. And certainly I don't have to have this set of parentheses that I've drawn in right here. I was just kind of organizing my thoughts. Okay, so I need f prime and g prime, right? So I have the same kind of scratch work for the chain rule that I would for the product or quotient rules. The derivative of x to the fifth will be 5x to the fourth. And x squared minus 10, its derivative will be just 2x. Right, so I have familiar scratch work here, but because I saw composition and decided it was a chain rule, I'm going to use these pieces to plug into this new formula over here. Okay, so my overall derivative, h prime of x, will be f prime of g times g prime. So this part of the formula is the trickiest part. So this isn't just a plain f prime of x. I'm not actually going to write 5x to the fourth anywhere. I want to have this function with this plugged into it. So f prime with anything plugged into it is 5 whatever to the fourth. And then I want f prime of g, so I'm going to put this x squared minus 10 into the input spot. Ooh, that's a minus. X squared minus 10. So this is f prime of g. And then I'll have times g prime of x. G prime is this 2x over here. So either with or without parentheses, I'll have a times 2x at the end there. Now, if the directions don't tell you to simplify, you can leave your answer exactly like this. Or you could go one more step, combine 5 times 2 into 10. So 10x squared minus 10 to the 4x. And certainly this x could go in the front with the 10 if you wanted to. Anything equivalent to this is a perfectly good final answer. All right, let's try another one. So my second example in this video, you can see here, we have the square root of x cubed plus 4x squared plus 1. And again, we can tell like overall this whole function, I don't have one derivative rule that just like covers all of this. So I want to start to pick it apart and say, well, is this two functions multiplied, divided, or plugged into each other? And this is another one where they're plugged into each other. So I want to see this as f of g of x and essentially do a decomposition problem to get started. I'm going to remind myself, because I see composition, I'm using the chain rule at the end. And I want to decide what the outer function f and the inner function g are. So my inner function g is going to be the whole polynomial because it's underneath that root. So the function that got plugged in is all of this. And again, that's something whose derivative I could do with my rules. And that would make the outer function f just root x, right? And I want to stop and double check once I've made this choice. Would f of g of x give me this original function, right? If I plug all this in here, do I land where I started? And we're good to go. All right, so now each of these pieces I can do with my regular power rule derivative stuff. The derivative of root x is 1/2 x to the negative 1/2 because really root x is just x to the half power. The derivative of g will be 3x squared plus 8x. All right, so again, the scratch work looks the same as it would if I decided to do the product rule or the quotient rule. But we decided we're doing the chain rule because we're seeing composition as like all this together. So my overall derivative will use this new chain rule. So from my scratch work, I want f prime of g times g prime. Right, so f prime of g. So this function, this is my f prime. Of g, I'm going to put this whole polynomial right in this spot. And then times g prime. So in this one, the g prime that I'm going to put in this spot is this 3x squared plus 8x. In the last example, it was a 2x, so I didn't put parentheses around it because it was just one term. But because this has addition, right, it's like this plus this, I need a set of parentheses to say it's times all of this. And I don't want it to look like the plus 8x is way on the end on its own. So this one has no super obvious simplifying, so I'm going to leave my answer just like that.